Hi everybody. We're going to get a little practice in finding the area of a triangle with coordinate geometry. It's really a pretty tough little exercise, but it's not unworkable and it doesn't have to take 30 minutes. I'll see if I can't do it cleanly with you and not rush through it, but show you that it doesn't have to take forever. So I'm going to start by graphing this triangle. You should do the same thing. I went left 6 and down 6 to find point A. I went to the right 9 and up 4 to find point B. And left 3 and up 9 to find point C. Let's see about that triangle ABC. We're going to find this area. And I understand finding the area of a triangle is not terribly exciting. That's not really what's important here. We're going to gather the skills that allow us to work through this problem. And those skills are important. They're going to make you a better math student, I think. We're going to call this segment AB. We're going to call AB the base of our triangle ABC. And it asked me to find the equation. Now, that could be a long production. We're going to do that carefully. I'm going to fit it in this space the best I could. First, I got to get the slope of AB, delta y over delta x. With A being at -6, -6, and B at 9, 4. You see, I write them all the time right where I'm going to work them because people transpose them and mix them up, and that's a big part of the problem. Delta y, give me a y-coordinate, -6 minus other y-coordinate 4. Give me an x-coordinate, -6 minus that x-coordinate 9. That gives me a -10 over a -15. And I'm telling you, the right thing to do is to reduce those fractions every time. We've got a negative over negative and 10 over 15. Let's call that 2 over 3. Much easier to work with. This line should have a slope of 2/3, but because I make mistakes and I make them all the time, I just don't always show them to you. I'm going to go look at this line. Does it look like it goes up 2 and over 3? And I'm saying really it does, doesn't it? In fact, I think I know the y-intercept. I could probably just write that equation, but I think I should probably do it with the algebra. Let's see. Let's choose a point. It's going to go through points A and B. I'm going to use point A, which is at -6, comma, -6. And this time I'm going to write that formula. Y minus y sub 1 equals m times x minus x sub 1. In a minute I'm going to work that without writing that darn formula. It gets cumbersome, and I hope you have it memorized. Y minus a -6, that's y plus 6, huh? And for m, let's use that slope of 2/3 times x minus the x-coordinate, -6. I'm going to call that x plus 6. Hey kids, let's multiply through those parentheses. Y plus 6 on the left-hand side. Don't be lazy. Clean this all up. Multiplying through the parentheses, we got 2/3 x plus, and 2/3 of 6, just 2 times 6 is 12, divided by 3, that's going to be 4. Isolate that y guy. I'm going to have to subtract 6 from both sides, and that yields y equals 2/3 x minus 2. And you might have been saying, hey, I figured that out a long time ago, and I did too. I got a y-intercept of -2, and it's got a slope of up 2 and over 3. Yep, we got that line AB, don't we? But now, this is getting more interesting. Work out the equation of the altitude from point C. There is a line that goes from point C perpendicular to line AB. There is a line that goes through point C perpendicular to line AB. It's going to look something like this, I figure. Something about like that, so it's going to be perpendicular. That doesn't look perpendicular to AB, and that doesn't either. It's going to be something right down the middle, something, I wouldn't say down the middle. It's not necessarily going to a midpoint, but something about like that. Looks about perpendicular to me. And we're going to figure that out, but that's going to take a couple of steps to get there. First off, get the equation of the altitude through point C. It's going to be perpendicular to AB. So I'm going to say, well, what would be the slope of that perpendicular? Well, since this line has a slope of 2/3, up 2 and over 3, then this one must have the negative reciprocal slope, -3 over 2, -3 halves. And what point you're going to go through, mister? Well, we're not going through A or B. We want the altitude from vertex C, so we must use its coordinates. There we go with -3, 9. Now, if you knew that formula, that y minus y equals m times x minus x, you wouldn't even have to write it down. You could just go with y minus 9 equals -3 halves times x minus a -3, that'd be x plus 3. And lo and behold, I got the equation of the line. I just need to work with it. Let's multiply through those parentheses. I got y minus 9 on the left-hand side. as I multiply here, a negative 3 halves times x. Here I have a negative times a positive, that'll be a negative. And 3 times 3 is 9 divided by 2. That's 9 over 2, which is 4 and 1/2. Just 3 times 3 gave me 9 divided by that 2 is 9 over 2, 4 1/2. Hey, but let's isolate that y guy on the left-hand side. So I got to add 9 to both sides. And that's going to yield y equals negative 3 halves x plus, now negative 4 1/2 plus 9. You know, 4 1/2 plus 4 1/2 does give you 9, so when I add a 9 to this negative 4 1/2, it's going to give me a positive 4 1/2. There's lots of ways we could do that arithmetic, but I'm going to stick with what I just did do, and if you want to ask about it, then we'll talk about how you can add 9 to a negative 4 1/2. Just 9 take away 4 1/2 gives me this value. Hey, does it look okay? Let's graph that fella. What's the y-intercept? Well, y-intercept's supposed to be 4 1/2. 1, 2, 3, 4 1/2, right about here. From there, let's follow the slope. Down 3 and over 2. Okay, I'll try that. Do I go up 1, 2, 3, 4? Better go up a little bit more. I didn't get that perfectly right. Down 3 and over 2, something about like that. Let's go through C and that point and hope it looking fairly perpendicular. I'm saying good enough. We're thinking we're perpendicular right there. I think I'm going to call that place point Z. When we think about the altitude, we're going to call that altitude CZ. I'm going to figure out where this line, the line AB, intersects this line CZ, and you may have a guess about it looking at that point right there, but I'm going to show you the algebra, and you're going to have to show me the algebra when you do this also. How do you figure out where these two lines intersect each other? Yeah, you're going to have to set them equal to each other. And with all these interesting fractions, let's do this carefully. 2/3 x minus 2 must be equal to y is equal to this and y is equal to that, so this must equal that. Negative 3 halves x plus 4 1/2. Now, a couple things to think about. I know I'm going to have to get my x's together. Over here they're negative, over here I like them to be positive, so I'll tell you what I'm going to do. I'm going to bring this to that side, and why don't we bring this 2 to the other side? We'll try to make it really obvious. Keep this 2/3 x on the left. But I'm bringing this negative 3 halves x to the other side. It's going to become a positive 3 halves x. On the other side of the equal sign, well, you got that 4 1/2. But I'm bringing that negative 2 to the other side as well. So plus 2. So I've done a couple things at once, but I hope you can follow that. We still have a little arithmetic to do. I'm going to add these fellows up, aren't I? I got to add 2/3 x plus 3 halves x. And I'm just going to do it the way I learned it when I was in 4th, 5th grade, something like that. I got to add these two fractions. And we're going to have to get a common denominator on them. This could be over, the common denominator would be 6. And this doubles to become 6, so this must double, it becomes a 4. Yeah, 2/3 same as 4 6. And this triples to be 6, so this would triple to be a 9. So when I add those up, I got 13/6. Yeah, and then interesting, 2/3 x plus 3 halves x, going to add them those up, and I got 13/6x. That looks terrible, but I don't think it's going to be too bad. Equals, and what have you got on this other side, mister? Well, I got 4 1/2 plus 2. That's 6 1/2, huh? For now, we're going to leave this way, this 13/6x. Leave that improper fraction. Let's make this an improper fraction so we can work with it. 13/6x is equal to, and as we make this an improper fraction, it's going to, you see, it's going to clean up nicely. 6 times 2 is 12 plus 1. We got 13/2. And why do you put them in this form anyway, mister? Well, we want to find the value of x. We've got to eliminate this coefficient of 13/6, so we're going to multiply both sides by the reciprocal 6/13. Let me multiply this side by 6/13, but I better come on over here and multiply this side by 6/13 as well. Keep everything equal. And I hope you think what I'm thinking. This 13 and that 13 divide to make 1. This 6 and that 6 divide through to make 1. I'm just left with 1x right there. But on the other side, 13 divided by 13 makes 1, so I've really got 6 divided by 2. I got 3. Lo and behold, I'm thinking the x-coordinate of that place right up there must have been a 3. 3 comma something. And I don't want to make any guesses here, man. I want to do this as it should be done. I think I'll use some of this space to do this. You don't got to do this twice, but I am. I got to find the y coordinate on line AB when x is equal to 3. It's also on line CZ when x is equal to 3. You don't got to do it twice, but I'm going to do this. I'm going to substitute 3 in for x in this equation and find that y value. Y will equal 2/3 of 3. Might think about that being 3 over 1 minus 2. That would be y is equal to 2/3 of 3 is 2 minus 2. Hey, that's giving me 0, huh? I'm thinking the y coordinate of that place might be 0. My graph isn't perfect, but it's pretty close. Let's try it in this other equation, see if it works the same way. I'm letting x be 3. So y equals negative 3 over 2 times 3 over 1 plus 4.5. Let's see what comes out of that. Y is equal to, and here I got a negative 9 divided by 2. That's a negative 4.5, huh? Plus 4.5. Man, I got y equal to 0 again, don't I? So I'm pretty happy with that. That place must have been at 3, 0. That must have been the coordinate of that place right there. So x is at 3, y is at 0. That's the coordinate of our point z. Now, let's bear that in mind. I got to put that where I can remember it. Z is at 3, 0. Now we're going to use the distance formula and find the length of AB and CZ. Make everything as clear as you can so you can go back and look at it, see what you're up to. A was at negative 6, negative 6. B we had at 9, 4. Doesn't matter that it was A and B, but it was at 9, 4. And we're going to hit it with my friend the distance formula. Do this little algorithm. Set it up this way, and you can find that distance too. All right. What goes in this first pair of presses? You tell me. Yeah, the difference in the x's. So we're just going to subtract one x coordinate, negative 6, minus the other x coordinate, positive 9. And then here the difference in the y coordinates, that'll be a negative 6 minus 4. Being as careful as I could, a negative 6 minus 9, that's a negative 15. But we're going to square it. And negative 6 minus 4, that's a negative 10. I'm going to square that one too. Negative 15 squared is the same as positive 15 squared. 15 times 15 is 225. Plus a negative 10 squared. Wow, that's a positive 100, isn't it? Let's look at that for a second. I got the square root of 325. Yes, sir. Now, let's talk about that. Can I reduce this radical? You know any perfect squares that go in there? There's one that's pretty obvious, huh? 25 goes in there, doesn't it? Yeah. That's 25. And how many 25s would there be in there? There's 4 in every 100, so that must be 12, 13, 25 times 13, I think, huh? Yeah, 25 times 13, 12 times 25 would be 300, isn't it? Yeah, so I know the square root of 25. This would be 5 times the square root of 13. Now, isn't that interesting? That's the length for segment AB. Now, we're about to get this length CZ. Is there anything that you know about CZ that I should know about ahead of time? And the thing that would be interesting is it's going to have that same square root. That's the beautiful thing about this problem. It makes it fun to work it. Let's get those couple of coordinates and see if that happens. C was at negative 3, 9. And Z we found to have been at 3, 0. Now it's not going to be this same value, but it's going to have that same radical. That's what I understand works every time. Makes sense to me that it would. So he's hitting it with the distance formula. He's finding the distance between C and Z. Here we go with the difference in the x's, negative 3 minus 3. And for the difference in the y's, 9 minus 0. This gives me a negative 6. We'll square it. This gives me a positive 9. You're going to have to square that too. Now, I got 36 plus 81. Look at that. I added that up best I could. I think it's 117. I got the square root of 117. And now, honestly, if I had not thought about this a lot, I might be bothered. I don't know much about the square root of 117. But I'm telling you, it's got to have the same radical here. So I got to ask myself, does 13 go into 117? And I'm pretty sure it goes in there 9 times. Check on that. If 9 times 13 isn't the same as 117, it is, isn't it? Now, I might not have caught that right away, but I know it had to have that same radical. So that's a nice thing to know ahead of time. Let's work on that square root of 117. I'm thinking it's 9 times 13. Me, I'm going around knowing the square root of 9, all proud of myself. So that's 3 root 13. That's the length of this segment, CZ. So we know the length of the base. We know the length of the height. Let's find that area of that triangle and figure out how many of these little square units could fit in that triangle right there. Because that's what we're really figuring out. And I'm not acting like the area of this triangle is the most important thing. I'm just thinking the mathematics that we get to use, that's a pretty serious bit of mathematics. Hey man, how do you get the area of a triangle anyway? Area of a triangle is a pretty simple formula. Learned it a long time ago. 1/2 times its base times its height. 1/2 times, what is the base of this triangle? Well, we called AB the base. And AB we found to have length, 5 times the square root of 13. Now I tell you, if you're multiplying with using this number and using the square root of 117, it would not have been pretty. But with these forms, it is going to be pretty. 1/2 times the base, that was 5 root 13, wasn't it? Times the height, and what's the length of our height? Yeah, it was 3 root 13, wasn't it? Okay, trying to make it so you can see it too. 3 root 13. So now we are nearing fruition. We'd like to get this right. You want to multiply these first? I don't think so, man. I don't want to know anything about 1/2 of 5 root 13. Let's just keep that half on the outside for now. And multiply these bears right there. Outside guy with the outside guy is going to give me 15, isn't it? And then the square root of 13 times the square root of 13, man, that's a square root of 169. Let's just keep that 1/2 for right now. 1/2 times 15. And do you know the square root of 169? Well, it was 13 times 13, wasn't it? So it must be 13. Now, I don't like 1/2 of this, and I don't like 1/2 of that, so I'm going to keep this an improper fraction. I got to figure what 15 times 13 is, and I'm thinking that's 195. Yeah. It'd be 150 and 45 more. That's 195 over 2. This is over 1. This is over 1. I just multiply straight across the bottom over 2. So I'm about to announce the area of this triangle. You could say 195 over 2, but I'm thinking that's about 97.5 units squared. So, if a little while ago you were thinking, well, how many of these little squares would I fit in this triangle right up here? You might say,